Hi everyone, welcome to my first episode in the series Pandas Tutorial for Beginners. So this is one of many episodes that I'll be making on how to use Pandas for reading data, analyzing data, and then manipulating and exploring data. All right, so just come back to this channel to watch more of such tutorials. So before I proceed, let me say that the notebook, this notebook, all the codes here, the notebook is available. So if you want the notebook, you can check the description box for it. The download link is there. So you can get it and then start practicing. All right. So this is what we are going to do. We need to first set up our system. And so that means that you need to make sure that you have Python installed on your PC. And you can use any Python code editor. So I will switch to this one. This has the content that we'll use. All right. Now, if you don't have Python installed on your PC, don't worry. You can use your browser. All right. So far as you have an internet connection, you can use your browser and then visit Google Colab. All right. So I'll leave the link to this platform in the description. So Google Colab allows you to run Python codes online. Okay, so you can use your browser, and I've already covered the details to run that. So with Google Colab, you can run your Python codes. You can even run Python codes that have been saved on GitHub. All right, so when you visit Google Colab, you have this coming up. So you can click anywhere to exit it, and then you can go to File, and you can click on New Notebook. So when you click on New Notebook, you have this coming up. All right, so that's what we do. Let's wait for it to load, and then we can proceed. All right, so if Google Colab loads successfully, you can just type, let's do this. This is just test. I repeat, this is just a test. We will start the actual practicals soon. So just print hello world. I'm doing this for beginners, so just press hello world. I think I'll have to zoom in a bit to make it larger. Hello world, and then just click on run. Or you can also use Alt and then enter. So any of them will run the code for you. Right. So if you're running for the first time, there's going to be some time delay because it's now connecting to the server. Right. So once it connects, then this text is going to be displayed for you. Okay, so once it's displayed for you, that means that everything is okay. So you can start the practical. So now let's switch to my notebook here. This one here, I call the skeleton notebook because it has the contents. We are going to cover all these activities. All right. So we will start. Okay. So this assumes you have set up your PC. So this is what we are going to do first. We are first going to import pandas. All right. And by the way, let me say that I will leave the link to the pandas page in the description so that you can read more about it. All right. Pandas is a powerful tool for data analysis, data crunching, data exploration. All right, so I use it a lot because I do Python activities a lot. So that's it. All right, so first of all, let's import pandas. All right, so if you want to import pandas, you can say import pandas as PD. Okay, so the as PD is an alias. All right, so when you do it this way, instead of always calling pandas by its full name, you can just call pandas by this alias. All right, so in case for a beginner you are wondering why we have this phrase, it's just to give it an alias, okay, a different name. So it's this one is normally used if the model you are importing has a longer name or has a longer part. Then you can use a shortened form to make things easier for you. Okay, so let's execute this command. All right, that is done. Now we need to do this. Our first activity is to read a CSV file. All right, I already have the example data, so don't worry, I'll show you where it is. All right, so we will need to read a CSV file. Now with CSV files, you can read it from a local PC, or you can also read it from a remote server. For this tutorial, I already have an example data which is here. Let's go there. I think I'll show it here. I had already opened it. Let's just look at it here. Yeah, so this is the example data we will use. I will leave the link to this report in the description box. Okay, so I repeat, I will leave the link to this page in the description so that you can get this file. You can download, or you can also leave it and then just check it out later. So before we read it, let's open it to see the content of this file. So there's it. Now this file contains some model performance. I ran some machine learning tasks. I was comparing the performance of the models. So I have these models here. So there's an ensemble model, a collection of models, and these are single classifiers. All right. So it was a classification task, and I got all these. All right. And then I also have the evaluation metrics. All right. So I have accuracy, precision, recall, left one score, Cohen kappa score, Matthews correlation coefficient. So these are all metrics that you can use to evaluate a machine learning classifier. All right. So these are their respective scores, and we also have the machine learning models. I repeat, this one is an ensemble. It's a collection of models, and then this one up to this one, these are individual classifiers. All right. So for now, you don't need to understand the contents. The focus here is to show you how to read files using Pandas. So you can always come back later to explore this data. But I thought I will give a brief description, okay, so that you will know what we are about to do. So this is the data itself. Now you can download data, all right, by coming to raw and then clicking it to save it. But with Pandas, you don't necessarily need to have the file on your PC. All right, you can use a link. So for me, I'm going to read it directly from my Github page. So I'll just right click this raw and I'll go to copy link. All right, I just want the link. Alternatively, you can click on raw. So when you click on raw, it's going to appear like this, and you can copy this link. All right, so this is the link that we are using. All right, so let's do this. Let's go back. Let's go back to this one, and then let's come back to our Python notebook. So we are going to read a file. All right, so if you want to read the file, we are reading a CSV file, by the way. You can first define the file where it can be found. So I'll say CSV file equals, I'll bring my quotes, double quotes. So I should have two of them, and I will paste the file name there, or the file link. In this case, it's a link. So I'm just going to paste the link there. All right. So this is just to define the file. Okay. So I'll define it now. All right. And now I'm going to read it properly using Pandas. All right. So if I'm going to read it, let's say if I say table format. All right. So in other words, it's going to be a data frame. So I'll say df equals, I'll say pd.read csv, and I'll specify the file that csv file like this. So this will read the file for me. So let's execute the command. All right, so the file is going to be read. All right, now you see the star, that means it's processing. I was reading from the server, so it will take some time, but now it's done. But if it's your local PC, then it's going to be fast. Now it's done. We have read the file. So I'll use this opportunity to let you know how to explore data using Pandas. All right. So I'll first do this df just to see the content. All right. So I have everything here. So I have the columns, model, accuracy, etc. I also have this number. These numbers here, these are indexes. Okay. They are used to make queries. They give a kind of unique IDs for each entry. All right, for each of the rows. Okay, so for each of the rows, now for columns, you have their labels already, but for rows, it's also important to get labels. So these indexes will serve as labels, so they are unique. You can use them to make queries. All right, so these are numbers, but you can also use text or any other character of your choice. We will look at that as we proceed. All right, so that's it. Okay, there's a beginner's tutorial, so I will skip a lot of details. It's just to give you an overview of the Pandas environment and what it can do, and then you can always proceed further. Of course, I'll make other tutorials where I go into details, so don't worry. I'm currently working on a tutorial where I go into details with reading files, so that one will entail a lot, so just watch out for that video as well. All right, now let's proceed. Now we've read this, all right, but sometimes you would want to get just the column names. Okay, I think there's a typo. I'll just correct it here. So get column names. Okay, there's the actual activity. So sometimes you want to get the column names. All right, instead of reading or displaying everything, all the information, you just want the column names. And so you can just say df.columns like this. So once you do it, it will display the columns for you. All right. So that's how we display columns. All right. Now we can also get the index names. Of course, here these are numbers, but let's try it. We will later make another query when we change the index name. So I can say df.index. All right, so this will give me this. Here it says range index, right? Because we are using numbers, and these numbers were assigned by default. All right, we did not specify any column for the index, and so by default these numbers were generated. All right, so you will leave it as it is. Okay, we will later make some changes, so don't worry. Just hang on. Just follow my lead. All right. Now, if you have your data, if you have a data frame, then obviously one of the things that you would like to do is to get the number of entries. So you have rows, you have columns. All right. You want to get a number. All right. So you can just say df.shape. So this will give you a number. We have 6 by 7. Okay. So we even display them here. So we have model, we have evaluation metrics. Okay, we have 6 of them plus this, that is 7. So that is what has been given here as 7. Now the rows are the records. Okay, this one here we have 6 of them. All right, so each is a record and there are 6 of them. So each row represents the performance of a model, a machine learning model. All right, so we have all of them here. That's it. Okay, so let's do this. If you have a data, you can also do some basic statistics. All right, so we can use this function to get it. We can say df.describe, and that will give us a basic statistics. All right, so we have the counts, mean, standard, deviation, minimum, percentiles, maximum, etc. So you can just use it to get an overview of your data. All right, so this one, you will notice that the model column, there was nothing there because that one is not in a numerical format, and so that has been skipped. So we have these numbers automatically being detected. You can also use a command to get data types as well, but that's something that I'll cover in another tutorial. All right, now let's start some queries. All right, let's start asking some questions. We want to explore our value. This table is for, let me just display it first before we proceed. This table gives us the performance of machine learning models. All right. So one of the things that you can do is to get the maximum value. All right. Okay. You have your values. You want to see what is the maximum value. Okay. We have all these metrics and all these scores. So what's the maximum value? You can just say df.max. Like this. All right, so this will give you a value. All right, so df.max. Now the df.max here will give you the maximum values for the columns. All right, so to give you the maximum value for the column. So there's a column wise computation. So you have model. Give us this, but of course model is not a number, so we also have accuracy. Accuracy is 0.7807. You can just check from here manually, you see it here. Okay, and then you also have the rest. So we have the metrics, all of them and their respective maximum values. All right, now let's do this. The model is these are model names. We don't really need to do some analysis on them. Okay, these are identifiers for the respective models. So because these are unique, you can actually make this the index. All right, so that when we are making the queries, instead of using 1, 2, 3, we have a more meaningful identifier or identifiers. And so before we continue with the maximum value queries, let's set an index. All right, so if you want to set an index, you can say df.set index. So this approach is used if you want to specify a column which is already in that data frame, the data you are using, the table you are using. Then we have a column called model. So we want to use that as our index. All right, so we can just bring our parentheses and we can say model like this. So let's execute this command. So we have it done. Now if you do it this way, all right, you see that the model column is now the index. But now let's type this df again. All right, you realize that it has reverted back to its old format or its old form, where the model is a column and then the indexes are values. All right, so this is because the command we made here is just going to display the outcome. All right, so it's just saved in memory. It doesn't reflect, it doesn't change the original data. So if you want to make the change persistent, there are two ways. You can either create a new data frame and assign the operation to it, or you can just call the operation and then save the changes. In this tutorial, we are going to save the changes in the original data. All right, so that's what we will do. We will come back here. I will say df.set index. I specify the column, and I'll say in place equals true. So in place will be used to update that data. All right, the data that you are manipulating. Okay, so let's execute this command. Okay, so when you execute it, now if you say df, we are going to find your table there. All right, so this is so cool. So now we have our table, which now has the model column as index. So from henceforth, when I talk about index name, we are referring to the model names here. These are the indexes, and these are the performance. All right. Okay. Now it's time to proceed. Let's get back to our maximum values. All right. So the maximum value, let's do it again. I made mention that the maximum value, let me just do it again, df.max. This one returns the values, okay, for the individual columns, the maximum values. All right. So get maximum value for columns is the same thing, df.max. That's the default. All right. That's the default. Okay. That's the default. Now, for switching between maximum value for columns and rows, like we have columns, we have rows. For switching, we use the argument access. All right. So by default, the access is 0. Okay. Let's say df.max access equals, let me just type it to access equals 0. Let's run this. So the access equals 0 is the default settings, and that is what returns the maximum value for each column. But if you want rows, all right, if you want rows, okay, then you need to change the access to 1. So that is here. So we can do that. So you can say df.max access equals 1. So that will return the maximum values per row. All right. So in this situation, it makes sense if we query for the maximum values per column, because each column represents an evaluation metrics. All right. So accuracy, if you want the maximum accuracy, okay, we have it as 0. Let's say 0. Let's check 0.7807. That's for accuracy. And so with accuracy, if you compare all the models, the best performing model had an accuracy of 0.7807. All right, so this we can easily interpret and then discuss. All right, now if we come to the row wise, which is here, let me just do a df here first. For row wise, we have ensemble, says the maximum value is 0.8003, but here the maximum value was for the precision. All right, so here comparing it and using it as a performance metrics is kind of tricky, because these metrics, their computations are different. And so in this particular situation, in this query we are making, it rather makes sense. It's more meaningful if you find the maximum value per columns, like we have here, per columns. If you find it per column, because for per column, you get a value, and that can help us to make selections, interpret, and understand the performance of the model. So in this situation, it's rather more meaningful to get the maximum values per column, and that is df.max access equals 0. Okay. We can also do the same for everything. If you want the overall maximum value, now we have the maximum value. If we are querying per column, we had this individual. Okay, we have them. And if you want to query for rows, we also have them here. But sometimes you may want to get the overall height, the overall maximum. All right, so to get the overall maximum, let's do it here. That one, we just say df.max. So let's execute this command. So the overall value, the maximum is 0.8044. That one is somewhere here. 0.8044. That is here. All right. Okay, so that's for the precision under precision. So the max, this is what it does. It first gets the maximum value per column. We have them here, and then all these entries, it also finds the maximum value. So that is 0.8044. So there are two things happening. It first gets the maximum value per column, and then it also gets that result. It gets the overall maximum value. That's what we have here. Now, if you want to get minimum values, then it's df.min like this. And then you get the minimum values. All right. So from here, since you know how to query by row and by columns, it's going to be assignment. Try to get a minimum value for the individual metrics, and then tell us in terms of the minimum which one performed the worst. The one which performed worst with respect to accuracy is going to be the one with the minimum value, right? Okay, so that's it. Okay, now with pandas, it's possible to also make plots. All right, so this is what we are going to. I'm going to demonstrate with an example here. We are going to generate a bar plot, and so you can do this if you want to make a plot. Let's just do a query here, df. Okay, let's say you want to generate a bar plot for the accuracy. Okay, we have individual models here. You want to get a bar plot for the accuracy. All right, all you have to do is just make a query. We will talk about more queries later on. Okay, you can say df accuracy, that's the column of interest, and you can say that plots kind equals bar. So this will give us a bar plot. Okay, so we have a bar plot, and you can easily compare. Okay, so with respect to accuracy, you can compare, and then you see that this RF is the highest. Of course, that's what we got, 0.7807. This was followed by this ensemble here and that. So if you have a bar chart, it allows you to easily compare, all right, because it's more visual. Okay, you can also generate pie charts, etc. But there's something I'm also going to cover in detail in another tutorial. Or you can also check the panel documentation. That will give you more information as to the plots you can generate. Okay, so here we just made a plot for just one of the columns. Why don't we try with another column as part of practice? Maybe we'll try. Let's say df precision dot plot and was bar. Let's do this. And we have that also here. This is a bar chart. Now with charts, you can also customize them. You can add titles, X label, Y label. Okay, so these are things I'll cover in other tutorials as well. Okay, so let's proceed. Now we have been making queries, all right, but I still brought this one here because here I'll show you some different queries you can make, because if you're analyzing your data, these are things that you definitely do. All right, so let's start with something. Now let's ask this question. Let me just put it here. Okay, let's say, let's check. Let's do this. Display model or models with accuracy score greater. Let's see, greater than, okay, let's do this. Greater than 0.77. Now let's ask this question. We are going to do everything in pandas. We are asking this question. All right. Now let me do this. Let me do this here first. Let me just display the df. We have here. Now, this is a smaller table, so obviously we can just check manually and find it. And even still, even this one, 0.77, you now have to find each of them and compare. Okay. Of course, here we just made accuracy, so you can just look at them and then manually check. But if you have data with lots of entries, then it's virtually going to be difficult or even impossible if you have lots of tables, or let's say lots of entries for that particular column of interest. So this is where programming comes. So this question I've asked, it's simple. This is what we do. If you want to make queries, you just call the data frame, in this case is df, and then you bring a square brackets, and then in the square brackets you make the query. All right. So what we are saying that the query, whatever we get, should return to us. Okay. So here you ask. So if you want to, as you say df, and then you bring a square brackets, and you bring your column name accuracy like this. Okay. It's similar to how we did this. We generated the plots like this. So here we just call df, and then we specify the column of interest. All right. So it's the same thing we are doing here. You call your df, the main df, and then in it you specify your column of interest. Okay, and you just say greater than 0.77. All right, so like this. So here we have the df. This is the question itself. Okay, but we want to ask the question and return all records that meet this requirement. That's what we are doing. Okay, now let's do this. I think it's better I start with the other one first. Let me do this here. This is the question itself. Let's just look at it. I think I'll come back to this. All right, I want you to look at what's happening. If I say df accuracy greater than 0.77, this is the question. Okay, we are asking this question, df accuracy greater than 7. That's the question. Let's execute this command. Now you see this happening. True, false, false, etc. All right. But this one, we have this is telling us which entries have or satisfies the requirements. In real situation, you would want to get the records themselves. You want to see the records. All right. So this is where the other command or the other code I was writing comes in. So you have your question already. You start with your df because the question you want to subset from that data frame, which is df. So that is where this comes in. This comes in. So this is there. Okay. And then you now bring your question in it. So you have df accuracy greater than 0.77 like this. Okay. So let's execute this command. Okay, so now when you execute it, then you'll get the output. Okay, so what is happening is that the indexes here will be used. Okay, the indexes will be, so all the indexes that are true. Here we see true, there are 2, ensemble and rf. So those indexes, okay, they will be used to get us those values. Okay, or those records. Let me just put it that way. So that's what we have. So if you take a look at these two models, they all have accuracies or accuracy scores greater than 0.77. All right, that's what we have here. Okay, so this one is simple. Instead of displaying your table and then checking them manually, which can be problematic or which can be difficult and can even lead to mistakes, you just use the power of programming and then you get this done. Okay, you can also ask more than one question. Now let's look at another question here. Let's just expand this. I'll just copy this. Okay. I'll just copy this here. Let's use something. I want to add something else. So we have accuracy greater than 0.77. And then, okay, now let's do this. Let's ask this other question. So let's say display models with accuracy score greater than 0.77, and let's add this, and let's add another column, and let's see F1 score greater than 0.7950. Okay, so here if you have this question, obviously we know the answer is going to be ensemble, but then how do we write it in quotes? That's what we are going to do. So here, that's what we do. For now, let's just put those questions. So these are the questions we are asking. DF accuracy, okay, greater than 0.77. We are also asking DF F1 score greater than 0.7950. These are the questions we are asking. All right, but we are asking, so we want a record that satisfies both. That's where the end comes in. Okay, so this is going to be the question if you are to write it. Okay, we have to do the final code. We bring our df, bring our square brackets, and then in it we'll do it. Now because we have two questions, if it's two or more questions, we add something else. To separate them, we use parentheses. So the first question, we bring it in parentheses. So that will be df accuracy, all right, greater than 0.77. And then the next question too, that'll be end, that'll be df f1 score. It's supposed to be in parentheses. Let me just correct it here. Yeah. So we say end, we'll bring our parentheses again. We say df f1 score greater than 0.7950. All right, like this. And then this one is already there. Okay, so we are good to go. So if you are still getting confused, you can just write your question somewhere like this, put them in quotes. Okay, so I don't get confused. And then you can just bring all of them together, so you can just copy them. Sometimes so it's better to break the problem into two or more, into smaller tasks, and then solve them. And then you add this. So this one, if a beginner, you will not get confused. You can do it this way. And then finally, you can copy everything. You can have your base command, your df in it, and then you can copy everything in it. Okay, and that will also give you your command. Let me just do it slow here. Okay, and that will also give you your command. Yeah, it's supposed to be this. Okay, let me just play it and paste it again. You just paste your command like this, and that is it. All right. Okay, so this becomes the final command. Okay, so if a beginner, you can just try it this way so that you don't get confused. But for me, I'm used to the Python environment, so I don't need to do all this. I can do it straight away, like what I'm doing now, which is this one here. So I don't need to go the long route, but for you, you have to do it. All right, so just take your time and then try it how you want it, and it will be done for you. Okay, so now this is the final command. So let's execute it. So when you execute it, you now have this. All right. So this is the one which satisfies both, right? The RF has an accuracy of 0. It has an accuracy of 0.7, which is greater than this one, and F1 score, which is also greater than 0.795. The F1 score is 0.7961. Okay, here this one here, the ensemble, the F1 score is 0.7950, but I want F1 score of greater than this number. Hence, we getting this results. All right, so this is the power of pandas and the power of programming. All right, so things are looking very, very cool. Okay, now you can also do some complex queries, ask questions and answers. For example, you can look at the maximum, you can also assign the maximum value to a variable, and then just make the correction. But anyway, there's an intro, and so for those activities, I'll go into details in separate videos. Okay, now let's do this. Let's try this. You have your DF. Okay, let me just display it again. Sometimes you may perform some computations or activities and you have some additional records and you may want to add them here. So if you want to add records, you can do this. You can add new columns. You can also add new rows. All right. Those are things that you can do. So let's do this. First of all, let's try this. Let's add a new column. Okay, let's add a new column. So if you want to add a new column, now we are adding just one, so I will remove the plural. It's very, very simple. Let's just say these are the metrics. You also want to add an additional metrics. Let's say an error. Okay, you can also add error. Then let's say you have the record already. Let's say you have the error. Let's say error equals, let's put it in a list. But we have covered list in detail. So for the list data type, if you want to learn more about this, just to the description box, there's a link to a video that shows you how to create lists and manipulate them. Okay, so that's it. Now let's do this. So we are adding columns, so that means that the number should be the same as this records here. So we have 1, 2, 3, 4, 5, 6. So we need 6, okay, because we have 6 classifiers. So let's just say 0.1, 0.12, 0.01. Okay, I'm just putting them like this. 0.2, 0.5, no, not 5, let's say 0.31, like this. Let's do it like this. This is just an arbitrary number, all right? So don't worry. 1, 2, 3, 4, 5. Let's add another one, 0.001, like this. So we have our list. All right, so 1, 2, 3, 4, 5, 6. It should be the same. 1, 2, 3, 4, 5, 6. Okay. So if you want to add your column, first of all, you need to have your record, and that is what we have here. And now you can add it. All right, so you can say df, and just bring it here. Let me redo it. So I can say df error, that's the new column, equals error. Now I have defined the error. There's the error. I have defined it here. There's a variable. All right, I have assigned it to this value. So me using this variable here means I'm using these numbers. All right. Okay, so you can also just assign it straight away, and that's also fine. But for now, let's do it this way. So I'll just execute this command. Okay, it's done. So if you don't want this one, then you can just clear it and rather paste your entry there straight away. I'll just do a copy and paste. For those who are comfortable with this approach, you can also do it this way. Okay, and that will also work. All right, so that's about it. So let's proceed. Okay, so for now, I've already assigned it, and so I can do it this way. I can just say df, and I'll get that one here. So there's it. Okay, we have that also here. So that's how we add columns. Okay, so this is the new table. We have the new column there. Okay, so that's about it. Now let's move on. We can also add new rows like this. What we did was to add a new column like this. We can also add a new row or new rows. Let's do that also here. Okay, so if you want to add a new row, this time we'll use another approach. We'll use that lock function. So if you want to add a new row, let's say we have the performance of another classifier. Let's say artificial neural networks, ANN. All right. So again, I'll just define it here first. I'll just say ANN equals, and now we now have, for column, we have 1, 2, 3, 4, 5, 6, 7. So I'll add 7 records. Okay. So each record represents one matrix here. So ANN, I'll say 0.7, that's accuracy. 0.8, that's precision. Let's say 0.778, that's F1 score. And then let's say for Cohen Kappa score, let's say 0.79. Let's say Matthew's correlation coefficient, let's say 0.53. Okay, let's put it that way. And let's say error, let's say 0.002. Right, so we have 1, 2, 3, 4, 5, 6. Are there 6? We have 1, 2, 3, 4, 5, 6, 7. Okay, I think we need one more. We need to add one more for record. Okay, so I'll just put it here. You can just put a number, that's fine. I'll just say 0.76. Okay, so that we have, so we have 1, 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4, 5, 6, 7. So let's first get our entry. All right. Now, if you're not sure of the number, you can just say len ANN and make sure it's 7. All right. Okay. So now we can proceed. Now we are going to add a new row. We first added a column. Let's add a new row. So to add a new row, here's what we do. We use the lock. So I'll say df dot locate, and then I'll do this. I'll say ANN. So here the ANN refers to an index. That means we are creating a new index, okay, which is ANN, and then the associated data is this one here. That's what we are doing. So equals, I'll say ANN. Right, we can do it this way. We can also paste the list like what we did the other time, the previous step. So you can do it this way and then run it. All right, so let's type df and then let's see what we have. So now we see that the entry has been added here. Right, you can also assign some of the activities, some of the operations to other variables, but for now we are just keeping it simple. These are things we'll cover in other tutorials. Okay, let's do this. Now let's proceed. So we have a lot of stuff down here, which is so cool. Okay, now we have added rows and columns. So how do we remove them? Maybe you have some entries you don't want and you would like to remove them. So how do you do that? Let's start. Okay, so we are proceeding now. So sometimes instead of the word remove, you also see drop. Okay, so basically they are referring to the same thing. We don't want them. Okay, there are different approaches for removing rows and columns. All right, but for this two, I'll just cover one or two of them, and then later on for a detailed tutorial, I'll cover various approaches for these activities. So as a matter of fact, what I'm doing is an intro. And so for some of the steps, there are different ways of doing it. It depends on the data you have. It depends on the data size. It depends on the data arrangement. There are a lot of factors. And so depending on what you have, then you apply the appropriate step or appropriate approach. All right, but this one will give you an overview of what to do, and then we can build on later. All right, so we are on removal of columns. So for removal of columns, I'll show you two approaches. Let's start with the first approach. Okay, so the first approach, we use the word del. So let's just say we don't want the error column again. We want to remove it. You can just say del. You can say df, and you bring the column of interest. Okay, so this one is just similar to you just saying df. By this time you've added the del to it like this. Okay, so del is to remove. Okay, so this can also be used on list as well. All right, so this will remove the column. So let's execute this command. Nice. So now if we do a df, you realize that the column is no longer there. Okay, so this is how we do. This is the first approach. Now let's look at the other approach. The other approach, I prefer to use that. That one allows you to remove multiple columns at a time. And so I prefer to use that. And so the other one, we use the drop. Okay, so the drop can be used for both rows and columns. Now we don't know what's columns, so let's see how it's done. So the other approach, I think I'll just add this here. So approach 1, and I'll add this one here. Approach 2. So approach 2, let me just, yeah, that's fine. So approach 2, we use a drop. So we say df.drop, and then you bring your parentheses and you specify the column that you want to drop. All right. So you put them in a list. Okay, so let's say you want to drop, let's just drop one. Let's drop this one. Or you can use any name of here. Okay, you can use any of these columns, that's fine. At this moment, you are just practicing, so you shouldn't use the exact same column I'm using. Okay, you can use a different name and see what comes up. So these are strings, so I have to put them in quotes like this. So let's say I want to remove this. Okay, this is what I'm going to do, and then I'll bring a comma and I'll say access equals 1. So this access argument is important because that will determine whether you are moving from the row, that's the index, or you are moving from the list of columns. Okay, so it's always important to take note of that. So here we are removing a column, so the access is equals to 1. You can put more than one column there, it's still going to work. So this approach allows you to remove multiple columns. So you can remove one or more columns. All right, so just go all out for this. Okay, so now let's proceed. So let's execute this command. Okay, and we can see it's done. It's gone. Okay, so we don't see that one there. Okay, of course, if you do it this way, let's just ODF again. If you do it this way, this is just going to display what the outcome will be. But if you want to make changes and then save it, okay, now if you do df, you get the column back. Or if you want to make a permanent change, okay, you can either assign this whole operation to another variable, or you can use the in place equals true. Okay, for beginners, for the sake of beginners, I'll just do this. I'll just use these two approaches. Let me just do it here. So let's just say new df. I can just do this. Okay, so now if I say new df, I have the new data frame with the column of interest removed. All right, this can be done, or you can just use this approach. You can just say in place equals true like this. You can say df, and you see that it's gone. But I will always advise you to be careful when using the in place equals true, because the change cannot be reversed. Okay, it replaces what was already there. And so to be on the safer side, you can always make a copy. All right, if you have your data, you can first make a copy which is there, and you can work on that copy so that the original one, it's always on chain. You can always go back to it. So don't worry, once you practice all these things, you become used to the system and you know your way around. Okay, so that's why I'm also giving you tips along the way. Okay, so now we can proceed. So let's do this. What we did was to remove or drop columns. You can also add another one. You can add other columns as well. So you can do this. Let's just paste this here. You can, if you have 2 or more columns you want to remove, you can add another one. Let's say F1 score, and you can also run it. All right, that will also remove both. Okay, so for that one, I leave it to you to try, and maybe in my detailed tutorials, I will show you all the approaches for dropping rows and columns. Okay, there's an overview. Okay, now what about rows? For rows, it's also simple. Let's say you want to remove the ANN. If you want to remove it, it's simple. It's also the drop. So you can say df.drop. You bring what you want to remove. And then when you come here, the access now becomes, can you guess? It now becomes 0. Okay, now becomes 0. So let's execute this command. Okay, so you can see that it's gone. All right, so this is how we remove or drop rows. Okay, so I'll leave the rest to you to try. Okay, now let's proceed. Sometimes too, in Pandas, you may want to rename columns. All right, now this column here, this name here, it's very long, so I would like to shorten it a bit. So I'll use this to show you how to rename a column or columns. Now for renaming columns, it's simple and straightforward. You need to first create a dictionary. All right. Okay. And by the way, I have also covered the dictionary data type in detail in other tutorials. So if you want to know what dictionaries are and how you can manipulate them, check the description. You'll find links to videos. All right. So just take note of that. Okay. Now let's do this. So first of all, you need to have a dictionary. You need to create it. So I can just say new names, or you can even say name dict. Any approach is fine. I mean, just know the name that you want. Okay. I'll say new names equals, and I'll bring my curly brackets. This is used to represent a dictionary. All right. So for dictionary, it's key value pair. So you put the old name first. Okay. This is the old name. And then you bring your colon and you bring the new name. Let's say new name is CA score, like this, or let's say CK underscore score. It's going to be the new name. So the old name, and then the new name. And so what happened is that Pandas will take a look at the table, look at the column with this name, and then since we are familiar with the dictionary, it takes a look at the dictionary and then it can now get the value, the corresponding value for that name, and then change it for us. That's what it does. So old name first and then new name second, like this. Okay. Or if you're also not sure, let me just show another one here. For beginners, you can just define it here, old name. And then you bring your old name, new name, CK score, and then in your dictionary, new names or name dicts, or you can say name dicts. You bring your curly brackets, and you can say old name, new name. Okay, that will also work fine for you. Okay, but I know my way around, so I'll just use this way. And I think this one is also straightforward, so you can just put it this way, right? So there's it. So we first have to create the dictionary first. So let's create it. And then let's just type it, new names, to get it. So that's there. And then we can feed this to the data frame. So we can just do this. Let's try it here. We can just say df.rename. And then in it, I will specify the dictionary, which is now new names, right? So here, if you have not created a dictionary, then you can just paste it here like this. Okay, and that will also run for you. Okay, that will be done. That's, I'll just, anyway, let's just try it like this first, and then you can try the other one. So you can just paste it like this, that will work. And then when you come here, comma, and you say access equals 1. Okay, so this is similar to the drop function. So if you are dropping columns, it's access equals 1. If you are renaming, the df of rename access is also 1. All right, so let's execute this command. All right, so now if you look at what has happened, you see that what? That column has been renamed. So we have CK underscore score. All right. Of course, this is just to display what will happen. So if you do a df, you get the original name back. Okay, so you can assign it to another operation. You can use the in place equals true. to make the change persistent. All right, so you can do it that way. You can also add multiple entries. So if you have a dictionary, if you want to add another entry, it's a comma, and then you bring your old name, colon, new name. You can bring another comma and bring others as well. All right, so the dictionary, it doesn't have to contain just one record. You can add more records as you see fit, or put the records or the columns that you want to rename in the dictionary, and then after that you can call them. You can call them like this. That also works. New names. All right. You can also do it this way, and this time, because we already have a dictionary, we just have to say new names like this. Okay, and that will run. So if you have not created a dictionary, then you have to bring the dictionary object there itself. And let's just add it here. Okay, so if you have not created a dictionary, then you can create it directly in it like this. If you have already created this, then new names, you bring it like this. So any of them should be fine. All right. Okay. Now I'll just paste it here. Anyway, the notebook is still available. If you want it, just tell us what the download link is. I repeat, the notebook for this tutorial is available. So tell us to download it. Okay. So let's proceed. So yeah, the notebook will be on my Patreon channel, which has other materials as well. So you can subscribe to the Patreon channel and get materials, okay, exclusive materials for your activities. Okay, so this is for the renaming of columns. Now what about rows? Let's just check. If it's rows, it's still the same approach. Okay, now let's do this. I want us to proceed. So let's take a look at this here. I made mention that using this approach will not save it. So if you want to make it persistent, you have to use the in place equals true argument as well, which I did here as well. You can try that and let me know what you got. Okay. So with the renaming of rows to the same thing, you create your dictionary and then you just proceed with that. Okay. So let's do this. Let's say once we rename this. So this one here, engine. Okay, this one here, this was an error. Okay, it was deliberate because I want to use it to show you how to rename indices. So the engine here is supposed to be NB, right? It's supposed to be NB. So if I want to rename it, then I can just say, let me just do it here. For now, I'll just use this new one. So I'll just say name dict, or let's say row. Let me do this, a new row names, because I bring my in brackets, I'll say engine is MB. Okay, so engine, I change to MB, so there's 9 base. All right, so I'll create this dictionary, new row names, and then this is what I'm going to do. I am now going to say df.rename, and then I'll bring my new row names objects, comma, and I'll say as this equals 0, like this. All right, so that's as this equals 0. And then this time, this is what I'm going to do. I'm going to save the changes. So I'll just say in place equals true, like this. All right, so let's execute this command. Perfect. So if you bring the in place, then it's not going to display. I repeat, if you bring the in place equals true, then the results will not be displayed for you. You have to do it yourself. So you can say df, and this will display it for you. So now you notice it has been changed to NB. All right, so this is so cool. Okay, so that's it. Now let's proceed. Let's do this. Now it's also possible to do a subset. Now you have all these entries. You may want to do some subsets. Okay, so if you want to do a subset, then this is what you can do. You just have to make your queries. All right, and then that'll be done for you. Okay, so for subsets, I earlier on showed you some stuff already, but I'll give different approaches here. So let's say you want to get the records for just accuracy, the accuracy score for all the models. All right, you can just say df accuracy. There's just one column, and you get it here. You can also assign it to a variable. I will show you how to do that. All right. Okay. Now, if you want multiple columns, then it has to be df. You bring your square bracket first, and you bring another square bracket in, and then you can now type accuracy. Then let's say precision, like this. Okay, so this one becomes a list. If it's just one column, that's fine. If it's more than one, it has to be in a list like this. So let's execute this command. This will give us the subsets. That's what we have here. Okay, so that's also fine. So now we are querying by column, right? Now we can also use this approach. I think that would be better. Let's just do it. This approach works, but there's also another approach which uses the lock and then the iLock. We will try all these ones later on. So let's do this. Let's try this other approach. Let's use the lock, right? So for the lock, you can say df, then you can say lock, okay, like this. So for the lock, you need to have your labels. So this is how the lock is. So in it, you specify your labels, which are the index or row names. This is the index, and then the column names or column names. That's how it is. So for the lock, if you want everything, then it's going to be comma. It's going to be colon. Yeah, it's colon, comma, colon. That means you want all entries, right? So this colon here represents everything for rows, and this one represents everything for columns. So let's execute this command. Now you see we have everything. Okay, so if you want specific rows or specific columns, then you can say df.lock. So this time, let's say you want all rows, but for columns, you want just accuracy. You can put it in list like this. Then we can execute it. So that will give us the records for accuracy. Okay, now let's try for accuracy and precision. So I'll just copy this list. I can just say df.lock all rows, and then this. That'll give me this, right? Now, if you want for rows too, you can just say df.lock. Okay, let's say you want records for ensemble. And we want all the records. You can bring this like this, and then you can execute the console. This will give you the records for ensemble. So here we want ensemble, the records for ensemble. We want all the columns for that. Now, if you want specific columns, then df.log. You can say, let me just use this list rather. So you can just add it here. Since you want just one record from each, let's say I want the accuracy for the ensemble model. All right, I can just say ensemble, comma, and I can say accuracy. Okay, now this one you can see we don't have any inner square bracket because it's just one record for row and then one record for column. So you can just leave those additional square brackets. All right, so let's execute this command. Perfect. So now we see it's for 0.7787. Okay, so if you say df, you have everything, and then you can just use this to get just one of them, one record or a few records. All right, so this is the power of programming. Okay, That's fine. So we can proceed. So let's do this. Now, let's say we want to subset and save that to a file. We can just do that also here. So let's just say we want to subset. We want just the accuracy and precision, all right? We want just those ones, all right, for all the models. Okay, I'll do this. I'm now going to save, all right? So I'll just come to this session here. Okay, so if you want to save, let's do a subset. So I can just say subset equals, right? Because we're just making a query without save, but I'm also showing you how to make the query and save the output. So let's say df. This time I'll just use our other approach. Okay, like this, and I'll say accuracy, precision, like this, and then I'll execute this command. So there's a subset. I have it here. And by the way, subset, this word here is a function in R. So if you are doing R, then I advise you don't use this as a variable. Okay, we are in Python, so we are safe. Okay, so now we have this. All right, so we can save this to a file. So I can say subset.tocsv. Right, and then I can save to a file. Right, so I'll just say subset.csv like this. Now execute the command. So now it's saved, right? Okay, so I am going to look at the outputs. Let's see. So I'll open my directory, the one which has it. So there's it. All right. So I'll just open it with my spreadsheet software, and there's it. I'll have it nicely done for me here. Okay, so everything is so cool. Okay, now this is what you need to note. If you are running Python, it's going to save it in the working directory that it has set. All right, so in case you don't find a file, let's go back to Python. I'll show you something. In case you don't find this file, just use this model, type import os, right, and then say os.getcwd. All right, so this will get you the working directory that Python is using. And so this part that you see, this is where the file is going to be saved. So you have to look, okay, check this part and then make sure it's there, and then just check it, and you are going to find the output file there. All right. Now, if you're working on Google Colab, then you have to use a different approach to get it. And that one, I've covered it in another tutorial, so you may have to do that. Or you can just try your best to install Python locally and then work and then get it done. All right, so that's how we do it. Now, let's look at something here. We need to look at this. It's important. Now, with Pandas Dataframe, we have the index. You also have your columns. And so with the subsets, we had already set an index. All right, so that is why when you open it, let's go back. When you open it into a spreadsheet software, you're going to see model because we have already set the index. So if you take a look at the notebook, if you type this, let's say df.index.name, you see it there. Okay, so by default, Python saves the data frames to CSV files with the indexes. All right, so if yours do not have an index name, then you may have to check and then appropriately name it. All right, so if you do this, let's go back. For the main data, which was df, we have already set, but if you had a different index values, then it will save that in addition. All right, so we can disable or enable some of the features with respect to including the index names in the output file, in the file that you are going to see. But this is something that we'll cover later. But if you also have a challenge, you can always let me know, or you can also read the Pandas documentation. All right, so that's how we do it. For those who would like to support this channel, there are links you can use, or you can also tip in proportion to what you've learned as well. And so that'll be all for this introductory video. And since you are done with Pandas, I also encourage you to check this playlist, which has tutorials on Python for machine learning. So check them and then learn how Pandas can be used together with other libraries to perform machine learning tasks.